The aim of this lesson is to provide a general overview on the exposure assessment, on the practice of exposure assessment. And the idea is to provide general information about the definition, about the characteristics and the main features of this approach, but also to focus a little more on the use of biomarkers for exposure assessment. Because nowadays, I mean, actually, the process of exposure assessment is quite complex, and many items, many endpoints can be used, maybe direct or indirect. And the general idea, actually, as I told, is to go in briefly in half an hour through the main approaches and the main characteristics of exposure assessment, and to see also what are the limitation and the point that must be considered when going through with this procedure. Actually, you have already received a few lessons about the generalities of risk assessment, and you clearly remember that there is different issues, different steps, I mean, and including the idea from hazard identification to risk characterization. Actually, in the middle of this process, exposure assessment is really a critical step. And I mean, there are these are. I mean, when you have to divide risk assessment in different steps, there are different interpretation of these steps. The most classic one is the one in which I mean, these are the steps that you see on the slide, and out of this, exposure assessment is, as I told you, a critical step in which this approach, this moment, this step allows us to determine or to estimate the extent of the exposure. And when I say extent, it means in a quantitative or in a qualitative way, the magnitude, the duration, and the route of exposure. And this is what we want to know. And but I mean, this is really a crude definition. There are more out of that. And so let's see one moment to start from the definition as usual. So when we see that what we mean by exposure, which is a classic event when a person comes into contact with a toxic material. So this is what really we want to assess. What does it mean come in contact? Come into contact with a toxic material is a highly dynamic process, varying from person to person. This is one of the first source of variability. And this inter-individual variability depends upon different behavior, different location, different lifestyle. And obviously, especially from different substances. There are more toxics and less toxics substances, but also substances that can be inhaled, substances that can be ingested, and other. I mean, and there is really a multitude of toxic substances, a multitude of physical and chemical characteristics, a great extent of different features concerning the persons. Each person is different. And so the same variability, the same exposure can be very different from person to person. And what is the goal of exposure science, exposure assessment, is to identify and characterize the real world contacts with and uptake in the body of toxic materials that can cause acute or chronic health effect. So the definition you see are always quite general. It somehow can be always so close to real life. However, when we define exposure assessment, this is a classical definition that we have. There is a contact in the boundary in between. I mean, the environment and the human body. And so we have to identify and describe a specific contaminant in a specific period, in a specific population, and a specific individual. The exposure at the end of the story identify the aim of I said a lot of words, but just if you had to focus, I can say that exposure assessment need aims to identify affected population, or better, exposed population, and calculate the amount, the frequency, the length of time, and the route of exposure. So this is not a simple task. And so if I have to make an outline of the process, there are like these main 4 steps in which we have to provide general information for each chemical. So this is really the first step in which we have here how is the chemical is transported, how is accumulated into the environment, into the tissue, how is transformed when it is released. Obviously, I mean, there is a number of different properties, means different transportation, mean different accumulation to the environment, obviously into the I mean, to have a lipophilic or hydrophilic substance, for instance, can accumulate in different tissue. This is quite, and the release of substances, it depends upon these characteristics, for instance. And also the point of transformation is important because, you know, there is a number of chemicals. Think about benzoylpyrene, for instance, which is transformed by, which is activated by enzyme that goes through an enzymatic activation. That means that the transformation, for instance, benzoylpyrene, which is transformed in diol epoxide, which is the active component. So that means that exposure maybe to benzoylpyrene, which is a kind of exposure, but is not really the part of exposure which is more relevant to the future health effect that needs enzymatic transformation. So this is something that must be considered, and also the opposite of activation, which is the detoxification. You know that we have different 2 big families of enzymes, the one activating and the type 2 enzymes detoxifying. So for instance, the detoxification of many compounds is an important issue to take into consideration. And obviously, and I think that in this point number 1, there is a previous point which is not reported here, which is the physical and chemical structure of the compounds and the toxicological properties that we know and that comes from the literature. And obviously, then once we know the characteristics, the general characteristics of the compounds, we can then apply in investigation about the transportation, the accumulation, and the transformation. And all these facts are important because they are going to determine the dose and the route of exposure, which are also critical points in exposure assessment. So the source of exposure, and exposure can, for instance, there are obviously several possible sources. One important and good example of the source of exposure, if this is inside the house, so where you have like cleaning products, paints, pesticides, and especially air pollution, what is called indoor pollution, which is generated by all these items, but also by the combustion that in the indoor the house can be really that can be even more important than outside because of the concentration of pollutants. But also we have outside the pollutants in the air which characterize of the outdoor pollution. And if you remember the list of before of critical issue, one is the identification of the exposure pathway and the environmental fate. And the first point, as I told you, is to identify the source. Then we have to look into the root and the nature of the exposure. That has to be determined. As an example, exposure is through drinking waters. So the drinking waters is the exposure, but the root, what is the root? Because obviously we can have just drinking, we can drink water which is not polluted. But the real root is, in this case, for instance, is ingestion of contaminated water. So it's quite clear that there is a different step and different definition of this different important critical events, which are dealing with source or route of exposure. And when we talk about route of exposure, just to be a little more clear, more understandable, that we have to look into route of exposure, which are through inhalation, for instance, the presence of dust, mist, fume, gases, vapor inhalation. So the exposure can occur through different routes, which entail inhalation. These are some examples. But also another critical, important route of exposure is the dermal, through the derm, through the skin, which is the dermal contact can occur with contaminated soil of dust or even especially contaminated water. I don't know, think about exposure into swimming pools and into chlorine compounds. And these have been demonstrated to occur mostly to dermal contacts. And the third major primary route of human environmental exposure is through ingestion. And ingestion is can be contaminated food, of course, but also the water or even the dust of the soil that can be present in food and especially in water. And then there is some special example, and one is dealing with children. Children that spend time generally outdoor, and they have this typical habits of hand to mouth. They bring their hand to the mouth, and if the hands are dirty, staying outside into the environment, dirty by soil, by dust, or by touching the different contaminated objects. When they move their hands to the mouth, there is a clear an example of ingestion. And then when we are able to measure and to assess all these steps, which are dealing with the way of transportation, with the route of ingestion, the route of exposure, that may be ingestion, may be inhalation or transdermal exposure. Once we have this reconstructed, this ways of exposure, we can use this information to measure actually a concentration of the compound or the active compound into the body. And how this is the fourth and most critical step. So we have to assess it, to define, to quantify the exposure. And this can happen in some circumstances through a direct measurement of concentration. So when we can measure, for instance, the agents, the concentration of the agents into the body fluid. In many cases, this is not possible. This is not possible because of the difficulties of identify an agent, or because the accumulation of the agent can happen in some districts of the body that cannot be easily sampled. think about liver accumulation, of brain accumulation, or of inhalation in the lungs. In that case, we will have to deal with estimated concentration. So when the samples are not available, we have to use mathematical models, and we will spend a little time on that. But the use of mathematical model can make our best guess of how much of compounds we have in our body. So how much the agent we are exposed to. And this can be done with mathematical models that we will see, that can be based on using data from the body. That can be the weight of the body, can be the, the surface of the skin of the body, and depends upon the root of the root. Because if we think, for instance, that the exposure is mostly through transdermal route, in that case, for instance, the skin surface may be the best estimation of the possibility to be exposed. If, for instance, we know that there is a fat accumulation because we are dealing with lipophilic compounds, in this case, the weight, the amount of fat in the body can be the best denominators. Obviously, mathematical modelings can be also into the environment. And so in this case, we have a sort of indirect exposure assessment, which is not the portion of the agents present in the body, but the quantity of the agents present into the environment where we live. And so it's an indirect assessment of how much exposure we can go through. And exposure obviously can be measured in different ways. I mean, obviously, I told you that we can measure the agents in the body, but there are some other indirect ways of exposure that may work quite well. The most commonly used is the questionnaire or the surveys. And think about smoking. So most of smoking habits are the estimation of the quantity of cigarettes smoked go through questionnaires. How many cigarettes do you smoke every day? So this is the most reliable way. Although we will see that using nicotine or cotinine in the blood is maybe a more individualized assessment. Also, there is the employment records. You can just investigate how much agents are used in that area. Think about, I don't know, pesticides. You can think about how much the particular pesticide is sprayed in the greenhouses. So we can estimate its exposure through the amount of exposure of the compounds which is sprayed in the air in a restricted environment. And also we can have also measurement of environmental pollution outside in the cities, if you are more interested in the environmental exposure, or into the workplace, if you are more exposed to interested in occupational safety, occupational exposure. And as I told you before, just to summarize, there are direct methods and indirect methods. And direct methods are based on pollution at the individual level, in which we have measurement of the compounds into the environment. And when I say at individual level, because we have personal monitoring, which is generally we have personal samplers which are applied to the person. So we can have a very good estimation of the compounds that may have been breathed or ingested during the day. And obviously biological markers, which is the golden standard for a direct assessment. Obviously, there are also indirect methods I anticipated, which is questionnaires, which are the measurement of the compounds into the environment, into the general environment, or we can do also modeling based on the environmental fate of the compounds or into the route of exposure. As anticipated, however, the golden standard for many issues is the use of biomarkers of exposure. Here, this is a quite very well known multi-steps pathway moving from exposure source to clinical disease. So there is a long story in between. There are a number of biomarkers that are dealing with just focus on the first part because these are biomarkers which are most dealing with the early event, early effect, and late effect, mostly dealing with the anticipation of the diagnosis or the prognosis to predict the prognosis or to investigate the etiology of the disease. We are more in these lessons. There are other lessons on these topics, but in this lesson, we are more interested in the exposure source, for instance, the presence of polycyclic aromatic hydrocarbons in environmental tobacco smoke and in the urban air as well. This is an exposure source, of course. Then we have the transportation and the fate, I mean, like inhalation or breathing cigarette smoke for the contact. Then for the first step, we have also the role of individual susceptibility. As anticipated, some very common compounds like hydrocarbon, polycyclic, PIH are they depend a lot on activation. There are a number of cytochromes that can activate different families of polycyclic PIH or detoxificate with with enzyme type 2. So this brings to the internal dose, which is the perfect measure of exposure, then which is the internal dose. Then there are other issues which are dealing with the individual body, the metabolism, the genetic profile, that in a way move from the biomarker of effect, from the biomarker of exposure to the biomarkers of effect, which is something which is out of scope now. Obviously, there is a different possibility in different part of the body that can be sampled, and always you have to remember that specific pathways can be affected by individual susceptibility. Then when we spend a little more time now in the biomarkers of exposure, that they are the product of metabolism, they can be measured in the urine, blood, saliva, hair, and the level is the concentration of the biomarkers in this different body district can be part of, can allow us to quantify individual exposure to the compounds. And obviously, when we look into the body, there is a huge amount of different parts of the body that can be measured. And I just bring here a few, like obviously the blood. Where is it? The blood here below me, and the blood, but there is also in the urines, but also in the hair, in the nail, in the semen, in the breath, in exhale, the hair, I mean, or in the exfoliated buccal cells, exfoliated nasal cells, in the bone marrow. I mean, there is a simple exercise that we do when this kind of lessons are in presence, in which a puppet is designed and people are invited to propose some possible human tissues or fluids that can be sampled. In general, there are dozens and dozens of different potentiality. However, when we think about biomarkers of effect, I'll make you a couple of examples. The best example of biomarker exposure is when we have a specific damage reflecting the specific exposure. And then we can have like those response cures. And this is the case of dicentric chromosomes in people exposed to ionizing radiation. I mean, the mechanism of damages, the genetic damage due to exposure to ionizing radiation goes through a clastogen effect, which is that means that chromosomes are broken by exposure to ionizing radiation. They are broken during interphase. So when there is the metaphase and we have chromosomes which are broken, they tend to recombine. And you know that generally they do not recombine because they are not balanced translocation because of telomeres that protect and prevent rearrangements. But when they are broken, these parts are sticky, so they are much more easily recombined, and many of them recombine forming dicentric chromosomes. So measuring dicentric chromosomes are not very common, so we have to score at least maybe 500 metaphases. So it's very complicated, the long-term exposure assessment because it's done on the microscope. But once we measure the frequency of the dicentric chromosome, you see that there are very, very precise dose response cures in between the frequency of dicentric per cell and the dose. And you see that in this way, you can easily reconstruct the exposure of each people based on the frequency of dicentric. Yeah. This is a very historical, very well working biomarker of exposure. Another very common biomarker of exposure is the frequency of blood of lead in the blood. So the blood lead assay is able to measure the micrograms of lead per deciliter of blood. And this is very efficient way because can recognize people that were exposed to high level of lead. This is a special of interest for children because levels upper to 10 milligrams of blood of lead per deciliter can induce mental retardation and several problems. And you see that, for instance, in the US, still in the 2012, there are at least in 6 to 1,200 children with high level of blood lead level that may induce mental retardation and other neurological problems. So you see that also in this case that may be very efficient. Obviously, this is very simple. The real life bring us to the example like the pesticides, in which you can measure the concentration of several compounds, but the problem is that when the exposure classes are very different because we may have occupational, environmental, dietary exposure. Think about the exposure of pesticides in the food, think in the skin of the fruit, but we may have fungicides, insecticides, nematicides, herbicides, and exposure assessment can be really, really complicated because we have mixture of pesticide. We have different exposure in different period of the year. We have, and even with a precise approach, a dietary or a dietary assessment is very difficult because of the complexity of exposure. So in this case, exposure assessment can be really not so easy and not so efficient. So when we talk about biomarker exposure, we have really, really a large number of examples, and I put some just for your, you can have biomarkers dealing with viral or bacterial infection. We have biomarkers that can be associated with the viral load, or we can have it to the serum autoantibodies or antibodies in this case. The same for allergen biomarkers. We can have different effect of allergens like xylazine, nitrogen oxide, nitrogen oxide, or think about, I don't know, celiac disease in which you can have some autoantibodies in the flow in the blood. Drug biomarkers, you can have again eosinophils, or the frequency, the concentration of some immunoglobulin, or pollutant biomarkers that are the ones we are dealing mostly, of course, as a toxicologist. I anticipated corticotinine, different metabolites, or metabolized DNA adducts or whatever. And also dietary biomarkers can be dealing with folate, DNA methylated, and so on. So there is really a huge amount of biomarker that can be used, and in many cases can be used to be evaluated together with indirect biomarkers such as questionnaires or exposure assessment. So exposure assessment, the exposure can be assessed through measurement, direct measurement, biomonitoring of individual, which is the highest way. Or we can use exposure monitoring. I told you in individual sampler. Then the quality is still reduced step by step, is lower. So exposure modeling based on the environmental data, or the concentration modeling, or the identification of sources. And we can use, this is very commonly used, I mean, the proximity. Think about the example I've been going through is the population living in Hiroshima and Nagasaki, in which the exposure to ionizing radiation that was measured several years after was tentatively measured by the amount of ionizing radiation based on the degradation of the enamel of the teeth, but that was really challenging. So it was used the distance for the fallout. So the distance for the people in Hiroshima, the distance from the fallout of the moment of the deployment of the bomb was considered a marker of exposure. So it's not so precise, but is the marker that they used. Or there is other, just to the end, we have what are called job exposure matrices, in which based on the the nature of the compounds and the kind of mention, for instance, people working welders. All welders have exposure to a number of compounds like polysaccharide, aromatic hydrocarbons, or heavy metals. And according to that, according to the job exposure matrices, an exposure can be reassessed. Obviously, there is a number of issues that must be considered, which is like obviously the size of the population investigated, the proximity. I told you the degree of personal contact with the site. If I investigate people living near a urban incinerator, urban waste incinerator, obviously there are people living there and there are people working there. So the time you spend near the exposure must be considered, or how many substances are released, if there are filters to the incinerator, or if there are not. And so there is a number of issues that must be really considered and taken into account. So actually, through this brief overview of exposure assessment, you have got an idea that this is really a challenging assessment. And obviously, the best approach is the combination of direct and indirect approaches, which is use all the information you have about indirect. So the source, the route of exposure, the modeling that we can do, the mathematical modeling of the environment and the individual, and to go accompany this measurement with a body measurement that may be coming from personal samplers whenever it's possible of the individual by use of biomarkers for individual real exposure.